Good morning, everyone. In this video, we will introduce the weighted nine tails problem in section 29.6. Please recall that in the previous chapter, in section 28.10, we presented the nine tail problem. And that problem in section 28.10 is an unweighted version. So please see this is the animation, and you're gonna flip the H cell. When you flip the H cell, and you're gonna also flip its neighboring cells. So this is the H. So if you flip on this, and this will be T, T, and this will be becoming H. So that's considered as one flip. So now we're going to have another one here, H. We're going to flip this. So all the neighboring cells will be also flipped. And now you're going to see this is everything is T. So the solution you have, this is minimum this two flips, and you turn all the cells into tail. So in unweighted version, you flip one, and it doesn't matter how many neighboring cells you have, and that's considered as one flip. But in the weighted version, so we're going to consider the neighboring cells too, add that in the weight. So for example, from this A to B, if you flip on this H, so you're going to have three. Weight is 3, so because 3 cells are affected. Now, from C to D, we're going to click on this H, so you're going to flip 5 cells. So the weight for this move is 5. All right, so we're going to construct our model. It's a graph that consists of 512 vertices. And they can be linked together and in the same way as before. But now we're going to add weight to each flip. So we're going to have this weighted nine tail model. And this is the nine tail model from the preceding chapter. So this is the tree, and here is the unweighted graph. It's the search tree. So we're going to have this is a search tree starting from the root. So that's the target, or the tails are in the board. So you flip everything to T. And this is the constructed nine tail model. And now look, everything we have here, it's now inherited by weighted nine tail model. In the weighted nine tail model, we have this constructor, weighted nine tail model. And this is to get number of flips. So we need to have this to know the number of flips for each, from one node to the other, one state to the other state. So this is to get number of flips from this state U to B. So this is static method. So this is the private and get all the edges in a list. All right, so here is the weighted nine tail model. So this is the one. It's from the UML diagram. It's a straightforward implementation. So here's a weighted nine tail. So you get all the edges, and to construct a weighted graph, and using this edge number of nodes. And so the number of nodes here we have is defined here in the in this. When you do this, extends nine tail model. So it's defined in the nine tail model. It's actually 5 12. That's the number of nodes. So we're gonna get the tree now. So here we're gonna get the tree graph dot get shortest path, and from this, the eventual target node, and with all the tails in the node. So this is the get age, and so this is the get number of flips, and that's, you need to have this number of flips, and for this is the weight. So when you create a new weighted age, so you have this, the nodes from V to U, and here is the number of flips. And that's the weight. All right, so here is the test program. What did 9 tail? So you're going to prompt the user and to enter the input and 9 characters as a string. And so create the model. So this is the created model, and this is the model here. We'll create the model, and now you can get the path. So the model that gets shortest path, and shortest path starting from this, okay, initial node and to the root. So that is the eventual target node with all the tails. So and get all these, and now you can print it to get the path, and so, and this is the number of flips for this. All right, so that is all for this section on the weighted 9-tail problems. Thank you for watching. See you on the next video.